Well, good afternoon, everybody. As you might have guessed, I'm very excited to have our guest on this week. And it's a topic that is relevant for anybody involved in industrial real estate, whether you're a tenant, whether you're a property owner, or someone just looking to learn more about industrial real estate. Electrical power, which is what we're going to be discussing today, is critical. And I've found over my career that it's one of the most important aspects of an industrial building, but it's also one of the least understood. So I asked an electrical engineer, Bryce, to come on the show, and we're going to dispel some of the notions about electricity. We're going to go over some of the key terminology, such as single phase versus three phase, talk about amps, wattage, voltage, and some of the things that people are going to want to look out for, whether you're a tenant leasing or buying space, or whether you're a property owner who's going to be a landlord. There are some key things that you're going to want to know, and I think Bryce is going to do an excellent job of talking about these. So, Wyatt, if you can bring Bryce on. Bryce, thank you once again for joining me on this call.
Thanks for having me. I appreciate it.
So I'm quite interested in this as well. I've got a little bit of an idea on power and electricity in general, but I'm also quick to defer to the experts. I never want to be putting myself out there as either an electrician or an electrical engineer, such as yourself. But I think it's also important to have a high level overview so you can at least have a discussion with whether it's a tenant or a property owner to talk about some of these key ideas and key terms. So I thought that that'd be a natural spot to jump into is even just talking about the difference between single phase and three phase power and where each are used and why they're used.
Yeah, for sure. So when you have an industrial building or any building in general, typically where you start out with is, well, you need to know what equipment is going in. Is it lights? Is there other motors? What size of the equipment? So first you start out with everything that's got to go in the building. Once you have an idea for the equipment that needs to go in, then you have to start figuring out, okay, well, we need to power all this stuff that uses electricity. So then from there, you have to start looking at the equipment that's going to be going in. It can all come in different voltages and different power consumption requirements. And so from there, all the equipment can either use single phase or three phase power. So single phase power is typically like 120 or 240 volt for at least our geographical area in like Alberta, say, Canada. And then there'll be three phase power. And so the difference is usually basically the number of wires that are coming in, and each wire carries an electrical signal on top of it. And the signals are not exactly the same to each other, but when you have equipment, it'll be often be rated like 120 volt single phase or 600 volt three phase. And so based on the equipment that you're going to be putting into your facility, you typically need to sort out if you need to, first of all, get single phase power into your plant or three phase power. And so, for example, for an industrial facility, often we'll pull in a higher voltage, like say 600 volt three phase power, and we'll do a step down transformer to off to the side, still have access to 120 volt or 208 volt single phase or three phase power. So typically for an industrial facility, you're going to be looking at using some more heavier hitter equipment that takes more power. So you come in with a higher, we'll call it higher voltage. There's different classifications of voltages, but a lot of it comes down to that there's a relationship between voltage, current, and resistance in the electrical world. And so there's a math behind it, but often what you'll do is if you have a piece of equipment that needs a certain amount of power, if you have more voltage, then you need less current in order to meet that same power requirement. So a lot of the times we'll come in with a little bit of a higher voltage so that we have to have less current on site, which lowers the size of your wires quite a bit. And just the current often causes overheating if you have a lot of it. So it keeps things a bit safer if you can lower your current. So there's different engineering stuff behind the scenes, and a lot of this just links down to there's Canadian electrical code and national electrical code for North America. There's different electrical codes that ultimately help guide the ship on. There's all these legal requirements that a system has to have in order to operate. And so part of the electrical world is you have engineering and then you have like utility. So utility, they're the ones that they charge you for electrical usage, versus the infrastructure itself has to meet like the electrical codes and all the legal requirements, everything having jurisdiction. So often it's recommended that for an industrial facility, you'd have an engineer involved who understands the codes, the legal requirements, that can take professional liability for the design to ensure that it's safe, accurate, and functional to meet all the codes, but also can technically just perform and meet the needs of the facility, whether it's a water wastewater plant, whether it's pulp and paper. There's all different types of industries, and each type of industry often has its own codes associated with it.
Maybe that's a good place to move over to, was how you mentioned that it was really dependent on the tenant or the company that's in there that's going to determine how much power they need, which will then set the requirements for what the building will either have to have or be brought in. So let's maybe look at that area first. How does a tenant or company, if they're buying it, how does a company look at how much power requirements they're actually going to need? What's the process involved in that?
And a typical tenant probably won't know that. They'll say, well, here's what I know. I need a facility that is going to distribute water to our town. So that's what we know. Now we need someone that can actually accurately tell us what that even means. So often a typical tenant will advertise they'll ask for a proposal. They'll say, here's the goal that we want to accomplish. They'll publicly advertise it and they'll say, hey, engineering firms, can you help us out with this? We'll pay you to figure out all the stuff and provide the recommendations. So then engineers would like bid to do that work. If they get the job, then they're going to actually do all the work behind the scenes. So that then the engineer would come in, they would do like hydraulic water analysis, can figure out based on population of the area, how much water needs to be supplied. Once you figure that out, then it's like, hey, now that we know how much water we actually have to deliver to this area, let's now figure out what kind of equipment can even distribute that. So then you have pumps. Pumps, they just rotate and they move water. So pumps all need different types of, there's different horsepowers of pumps is the often term that you'll hear for pumps, for example. So the engineering part of it is to figure out the equipment that can actually provide the needs of the tenant. In this example, it's water, it's providing water. So the engineer will first then figure out so we got the water that's going to be needed. Now we start figuring out equipment. Well, what pumps out there on the market can actually provide that amount of water movement? So then from there, now you start adding up all your equipment. So you have this equipment list with all the different horsepowers and loads. So now that you know that there's 250 horsepower worth of equipment that needs to go into this facility just to move the water, then you also start looking at, okay, we also need lights, receptacles, we need some heating and ventilation units for the building. Are there any other processes that we have to have in this system as a whole? So once you have this master list of everything that needs power, that can all get converted into a number like kilowatts. That's what utility likes to see. They like to see like how many amps is this site going to need and at what voltage, and what are your loads, like what are your motor loads. So they have these kind of questions that they want to know up front. And so that's where you kind of need to know the equipment that's going into your facility to meet the needs of the tenant. And sometimes that equipment is only available at certain voltages and powers. If you're going to buy a 100 horsepower pump, you're not going to get that at 240 volt single phase. So sometimes you're limited by just the reality of what's on the market and what products physically exist in order to actually provide the needs of what your tenant is looking for.
Yeah, that's really interesting, and it reminds me of a development that's occurring right now, where we're starting to see more robotics go into some warehouses. Like, some of these distribution companies are starting to incorporate more robotics, and for the most part, if they were just a distribution company, they probably had a minimum power requirement. Like you said, that they still need the lights and the HVAC and the different equipment in there, but these companies didn't necessarily have a huge power requirement before. But if these companies are now going to start incorporating robotics, which I think is going to be a trend going forward, that's going to require that much more power in there. So is it the similar process where you're trying to analyze what draw those robotics are going to have from a power standpoint and then incorporating that into the overall plan?
Yeah, exactly. And that's where a lot of the engineering challenges can come into play is when you start with an existing facility that all of a sudden you're really going to beef up and add a bunch of stuff to it. Sometimes at that point, if you can't even get equipment in that same voltage range of what's already to site, sometimes you have to upgrade your facility, upgrade your site service. So the ideal case in those scenarios is you already have like your utility company already has three-phase power infrastructure developed in the area, because then you're just doing a site upgrade with utility. You're coordinating that. They're going to just kind of provide some additional infrastructure. There might be a capital cost associated with that, but typically when you have that case, it's more or less you're just working with utility to kind of upgrade a few pieces of infrastructure. You'll probably have to provide some new cables and some electrical distribution equipment in the building. But that's an easier retrofit. Where you get to a bit of a crunch is when you don't even have three-phase power available in the area from utility, in which case then that's where you enter some oddball cases of like, okay, well, is there just one piece of equipment that needs three-phase power, or is there a lot of things? Because there's options. One is you got to work with utility to upgrade to provide three-phase power to site. That can be costly. Sometimes it can be $100,000 per kilometer of newly developed electrical power lines and distribution. Sometimes it'll be like, okay, well, 85-90% of things can actually still be single phase. It's just this one thing that needs to be three phase. So then there are single phase to three phase converters. And there's also, for example, for my industry, water, wastewater, if we have pumps that need three phase and they're small, we can use different technology like variable frequency drives to convert single phase power to three phase power. They already do that conversion integral. They can do that conversion integral to its product if you spec it out properly. And then you can just power that one load. That's the oddball outlier with your three-phase power. So once again, it comes down to what the equipment is rated for, what it needs, and what it can be specified as. If you just can't buy that product in single phase and you have to go three-phase, that's where, as engineers, for example, we have to kind of take that as like a design challenge. And sometimes there's more than one solution to get to the end. So it's up to us to try and figure out what is the best solution to get to the end, which includes not only just the economic side of things, but also the safety and the reliability. If you have to put in 10 things that could each fail to get to your solution, and it's cheaper, slightly cheaper than just doing a more robust solution, maybe it's better to spend that extra income now, that extra capital cost now, to provide a more reliable solution than something that at the moment could be cheaper, but it's less reliable.
Yeah, that's an interesting point. And why I just put up a banner there. If you do have any questions for Bryce, please feel free to ask them in here as well. We'll try to get to as many as we can. And I saw Beverly joined in. Beverly, thanks for joining in. But yeah, I encourage you to ask any questions. So I want a hypothetical situation here. Let's say there's a company, it's a CNC company. So they have some lathes and some mills, and they want to get an idea of how much power they're going to need in a building. So they hire an electrical engineer, and you come to them, you audit the amount of equipment and machines and lighting and HVAC. What do you present them with in terms of what specs they need to find in a building?
Yeah, and so that's a good question. Normally what we would do on the engineering side of things is we have like single line diagrams where it's just a block diagram that shows right from utility. Utility comes in, and then we have to incrementally show each kind of piece of equipment, each load as we go. And then typically just develop either like a chart or an itemized list of all these different loads, or on your diagram, you'll have all the different higher loads. So often we'll be calculating out your expected demand and your peak demands based on like what the process requires off to the side. And ultimately, that's going to be going with utility. Utility is going to be asking for that, basically that load list, or at a minimum, how much amperage is going to be coming in. Now there's peak demand and there's typical operating demand. So we have to look at what the worst case scenario is. All your equipment's turned on. That can be turned on together. That's expected to be turned on together. And also just like on your average day, what equipment is turned on. So you have two different scenarios. We take those together, and utilities have application forms and application processes. And usually they're looking for those numbers. And so whether it's tabulated off to the side, on the engineering side, the electrical realm, single line diagrams are kind of like the main electrical drawing that would capture that kind of info. And it's just a schematic level block diagram kind of flow of how the electricity comes to utility, goes to your distribution equipment that points at different equipment with breakers and says that load gets this much of electricity, that load gets that much electricity, and it breaks it out so that it's spread over your page. And then from there, now you at a glance, you can just see on one or two pages your entire facility's loads. And then from there, it gets a little bit easier to visualize. Like, okay, now as an engineer, I can see that we need a box over here on the wall to manage distribution to that equipment and that. Then collectively, that all funnels back to utility, and utility is kind of the key thing there, where you don't have power unless a utility company provides it, or unless you're going to power your facility with like a generator or something like that. But that's kind of, I guess, a separate kind of beast. So for now, we'll focus, I guess, on utility and assume that a utility company is involved. And so ultimately, it comes down to knowing the loads that your equipment needs to have. And that's why there has to be like a design process to really lock that in. You might know upfront, like maybe it's somewhere between 200 and 250 kilowatts that your site will need. But it's not until you get into the weeds of the design to lock things down and confirm those calculations where you can actually shore that up and say, oh, it's actually specifically 185 kilowatt is your expected peak demand. So from that, now we can go and ask the utility company, hey, based on this, I need a 200 amp service. Can you guys do that for us?
Is that, oh, sorry to interrupt.
Oh yeah, no, go ahead.
Is that a natural, like, is that the calculation? Like, is it, you determine the kilowatts that you're going to draw as the tenant, and then it corresponds to a certain amperage?
So voltage, so power is just voltage multiplied by your current. So there's a relationship between voltage and current. So when you look at like say a pump data sheet, it will tell you how much current it's going to pull at what voltage. So when you do the math with the voltage and current relationship, that gets converted to kilowatt. And kilowatt is kind of a unit of power, like wattage. You know, if you buy a 100 watt bulb for your lights versus a 60 watt bulb, the 100 watt bulb is brighter than the 60 watt. And that's because it's using more power to produce more light. Similarly, with any device, if it's going to do more work, it needs more power. And so the watt is just a measurement of how much work that piece of equipment is going to be doing. So the heavier hitter equipment, a pump that's got to move a lot of water might have a higher horsepower than something that really doesn't do much. And so that's where it goes back to the engineering side of things, where we have to confirm the equipment that can actually perform, it can physically do the work to meet the needs of the tenant, whether it's moving water, whether it's manufacturing pulp paper, all that kind of stuff.
When we talked a week ago or so, you had a good analogy for the difference between amps and voltage. Can you share that again?
Yeah, so just think at a high level, it can be hard to visualize what's happening with electricity because we can't see it. It's happening in cables we can't see. But if you envision like a river, so the force of the river, if you're going to go floating in the river, the force of the water would be equivalent to the voltage. The flow rate of the water would be equivalent to the current. And then the rocks that might be in the middle of the river, that would be like resistance. And so often there's a relationship for electricity is voltage is current times resistance. So you kind of think of it like the force of the river is like the flow multiplied by your resistance. The rocks in the water is kind of a cheat way to kind of envision what's happening with electricity in the wires.
Yeah, I think that's a great analogy, and I might seem like I'm really asking you to dumb this down to my level, but I don't have nearly the knowledge you do on electricity, so I really want to try and simplify this as much as possible. So I'm a tenant. I've got a list of requirements on what I'm going to have for load, and you've got the peak load as well as what your typical operating load is going to be. So you would come, or the engineer would come and say you should be looking for a building with 200 amp power, three phase. Are you going to say what the voltage is as well, or is that enough? If you get 200 amp three phase, is that enough information for a tenant to go and find a building and have comfort that it's going to serve their needs?
The voltage does matter on the. So the utility company is going to provide a transformer that is going to step down their power line voltage down to the voltage that your site needs. Now the voltage on a power line is typically very high, and that's to minimize the amount of current that's flowing through all those wires. Because as you to provide the same amount of power, voltage times current. So if you increase voltage, you can lower your current. So the catch is the utility company is typically the one that provides that transformer to step down from their voltage down to your site voltage. So at some point it will be relevant what voltage it is, but at a minimum, as just a preliminary gut check, if you just want to try and coordinate with utility to be like, hey, I know that I'm going to need three-phase power, utility company. Do you have three-phase infrastructure developed in this area? Here's my legal land description. Here's my address, my civic address of where this facility is going to go. Can you guys advise if there's three-phase in the area? And then if they say, well, yeah, it looks like we have infrastructure developed in the area, then you're like, cool. So I can proceed with getting you more detailed, specific information, but knowing that you're not just going to reject my application because you guys don't even have that voltage in the first place. The ability to get us so really at that point, it's the phase does matter more at that point
Mm-hmm.
to know if you can even, because once you know there's three phase available, you can do 208 volt three phase, you can do 600 volt three phase, 480 volt three phase. There's higher voltages too, where you get into like medium voltage category, which is like over 1,000 volts. And so it's a lot of it just comes down to the equipment that you're going to be putting in and what it's rated for. And so it's kind of, I guess, a bit of a chicken and egg thing where you just have to have an idea of what kind of equipment is going to be going in. So that's where a lot of projects, they'll do preliminary design and then detailed design. Now, preliminary design is fleshing out all those minimum requirements enough that you can make an informed decision on how you want your facility, which route to be taken. And then detailed design is locking in the very specifics.
So, and this might be an obvious answer for you to answer, but it's still just a question that I would have. So, a tenant's looking at a building, it's advertised 200 amp, 208 volt, three phase wire, and they've reason to believe that that's been confirmed. Is that enough for you to go on as a tenant to say, okay, this we believe that this is what the power is in here. We believe that this will meet our needs. Is that enough to go on, or do you have to do a much more detailed analysis to actually confirm that?
If it's unknown, honestly, the easiest way is that building is getting power from a utility company somewhere, and there should be like a transformer or something that has a serial number. So you should always be able to go back to utility company, even if it's just the address of the place,
Mm-hmm.
and confirm it with them. Utility would have the records of anything that they're providing power for, because they're going to have utility meters that are measuring the amount of power that can actually confirm. And those utility meters will often have a lot of info on them as well. So if there's any skepticism on what even power is coming into that building, usually the most reliable way to confirm that is to look for the electrical infrastructure that is actually providing power into that building, and then go back to utility would be the preferred way to probably be recommended to go if you're just like in limbo land and you don't know for sure.
Yeah, anyone that's tuned into this, I echo all your comments, Bryce. And just a quick story that this actually happened to me about 10 years ago. We were looking at a building, and it showed the panel inside the building was a 200 amp power. That was marked on there. But when we actually started working with getting servicing in there, the service provider said that it was actually only 100 amp. So what turned out is that there was a lazy electrician out there that reused an old panel, which just happened to be a 200 amp panel, but they put it on for the 100 amp service. So I would just encourage people that even if it does say that, the last thing you want to do is warrant or represent that that's the power that's going into the building, only to find out that it's something different altogether. So and like you said earlier, Bryce, there's two components to it. There's the panel and the infrastructure in the building itself, and then there's also the service provider that does it. Is that typically like an easy process to go through, to just call the utility provider and ask them what service they have going in there?
It depends on the utility company. Some of them will ask you a lot more like, well, why do you do this info? What are you doing? So they might try and get more info to confirm, I guess, the reasoning on why you're doing it.
Mm-hmm.
If you're phoning on behalf of a tenant, then often they won't release that info to you without having a third-party authorization sign off from the actual owner saying, well, I was given permission to talk to you on behalf of them because I'm the one that has like the technical background that knows what I'm talking about. So that's kind of, as long as you have authorization working with utility companies, they're pretty good usually. So that's fine. But kind of going back to your panel idea, your item there. So there's equipment it's what it can be rated for, what it's versus what it's actually using. So you can have a 200 amp rated panel, which means you can get up to 200 amps going into it, but that doesn't necessarily mean that it's using 200 amps. And that's kind of where it goes back to like cables can come in all different sizes, different diameters. The bigger your cable, the more current it can pull. And the insulation has different voltage ratings. So if you don't have the right cable already connected to that utility transformer, that's a bottleneck where it's like, oh, so you want to upgrade your facility from 100 amps to 200 amps of current being pulled. That's good. That's cool, but can the cable even handle that upsize? Because a lot of our retrofit jobs, that's part of the process is we assume by default, unless we can prove through like field investigation, that the cable also has to be replaced and upsized to the appropriate cable that can pull the amount of power, the current. And so that's where if we're going to be doing a retrofit to an existing facility, sometimes there's a little bit more infrastructure other than just getting the utility transformer upsized. Sometimes you actually have to take out all the wire. And even if your panel has capacity to take it, you might still have to rip out all the wire going to it just so that you can properly and safely operate your system.
Yeah, and I'm glad you brought that up, because that is a question that comes up quite often, especially in like a multi-tenant building where there might be, 8 to 20 different tenants in there, and in individual bays. As a result, it quite often comes up that one tenant needs to perhaps double their power. So maybe it's a 100 amp three-phase service in there right now, and they require 200 amp. It goes beyond just whether that amount of power is even them building. It's whether that the cabling can handle it. So without giving like numbers that are concrete, but just even like a generic idea so people can have an understanding of it, what's typically the cost involved, even on like a soft cost, on going and doing these studies on whether it's even feasible, to the hard costs? And again, you can just give like a ballpark. It doesn't need to be, because everyone's going to be in different areas, and it's not going to be the same, but just ballpark for soft costs and what people could expect. And then also on the hard costs, knowing that every building is going to be somewhat unique and scale and size.
Yeah, I guess it would depend on how complicated your site is. If you're talking to like a single building that you're looking to analyze, it could be like in the tens of thousands of dollars to try and like figure out all the specifics, and make sure that the engineering recommendations behind that are considered. So I'm kind of thinking like this is like a design report that an engineering firm is looking at collectively everything. So it's like, we're going to look at your power requirements. We're going to look at we're going to look at also like to meet the needs of your facility, we're going to analyze the process to confirm the equipment selection. If this is a big detailed report that's telling you everything about your building, the electrical portion would probably it'd probably be in the tens of thousands, I think would be the rough off the top of my head guesstimate on if we're going to properly analyze everything and it's a true retrofit. Retrofits cost a bit more upfront to figure out as opposed to like a new project. If you're going to build a building brand new, usually on the engineering side, it's, we'll call it easier because we get to, right from the beginning and down, we can just put in all the requirements. We can start all the calculations right up front and get that all tailored. Versus a retrofit, you have to do some recon. You have to look at existing as-built. You have to potentially do some site investigation and go to and actually open up panels. And worst case, you have someone like expose that line, which is could be underground. So then all of a sudden, now you have to rent equipment to expose that. So that's where costs can really start adding up in a retrofit investigation, depending on how accessible things are in site and if you can even find that info, how accurate as-built info is. So it does vary, but we call them like greenfield projects versus brownfield. A greenfield project is you're building it fresh. Brownfield is like a retrofit. So greenfield projects, we would kind of start with the end result of like, well, here's all the equipment we need. Then you start working backwards towards the utility line to get all the infrastructure developed and sized appropriately right off the bat. As opposed to if it's a retrofit, you kind of have to go the other way around and see like, well, what's my bottleneck and limitation? Utility service is only this size, which means the cable here, let's look at that. How big is that cable? So then you have to start figuring out, well, based on this, you can't even connect all of that process equipment without upgrading your whole like service size and your cable, and that panel has to get upsized. So retrofits often have a little bit more design work up front in order to flush out those bottlenecks.
Yeah, well said. I want to go back to the part you mentioned a couple times about the transformers, and that's basically just to step down the power. So if the utility provider is bringing in a certain amount of voltage, but you have to step it down for the equipment that's in there. I've noticed that there's some buildings that don't have a transformer. Does that just mean that the transformer is perhaps on the power line, like what you have in the picture behind you, or does every building require a transformer to step that down, or are there different scenarios?
I have yet to see a case where there hasn't been a transformer on any projects I've been on, but there's pole mounted transformers and then there's pad mount mounted transformers. Now, a pole mount is a transformer that looks kind of like a big cylinder that hangs on the pole,
Mm-hmm.
versus a pad mount transformer is on a concrete pad on the ground, typically close to your facility, and it usually kind of a smaller service will have a small pole mount transformer, like say up to 150 kilowatt facility might have a pole mount transformer, and then anything up from there might have a pad mount. That exact number is not concrete. It changes based on geography and your utility provider and their standards and what you request. Sometimes you can even request one versus the other if it's in between the sizing requirements. But if you're in like a town, sometimes they might already have like developed like a distribution system that you have to work through like the city to get approved, and they'll kind of deal with that on their side. So if you're doing just a standalone industrial facility, often the typical is that there's a utility transformer involved, although there might be some few special exceptions there where they might use like they call it like switch cubes, where it's like a box that you can tap. Eventually it reaches either like a substation or a transformer or something. But whether or not it's like really obvious and right next to your facility versus it's more upstream, usually at a minimum that still has to get those specifics will get flushed out when you are talking to utility, because once again you can't power anything without power, and therefore those that provide power are the ones that can advise on specifically the infrastructure that they're going to be recommending to get put in, whether it's a transformer, whether they just say, oh, just provide a conduit to the property line, we got your back, we got you covered from there. Sometimes utility will have special infrastructure already in place.
Oh, that's very interesting. So is there ever a scenario where you would step down the power that comes into the building and then step it up if you've got certain machinery that requires more power, or is it only ever step down?
The typical from the engineering side of things is you'd come in at the hot, you'd step down your transformer from utility to the voltage of your highest rated equipment and start there. And so think of it that you do a step down transformer outside from utility. Then you come into this big enclosure that manages like 1000 volt kind of thing. And then from there, you might have other equipment that needs 600 volt. So then you'll do another step down transformer that would be customer supplied, not utility provided, and step down to 600 volt, and then do another big enclosure that has all breakers in it. And then you might have lights and receptacles that are like 120 volts. Then you do another step down transformer, either from the 600 volt system or the 1000 volt system. Both are options there. And then have another panel that distributes. So you end up having these different boxes. You can envision them side by side. Each one handles a different voltage, and each one has had step down incrementally as you go, different voltage levels. And so then you pull from the different boxes that have all the different voltages associated with them to the respective equipment that needs that specific voltage. So I personally haven't seen a project where it's brought it down and then brought it up. Normally, the typical is you start incrementally decreasing your voltages down subsequently.
Yeah, that makes sense, and I think that just underscores how complex this topic really is. I've been in the industrial space for a while, and I still have a layman's level knowledge on this topic. So I think everything you've said so far has really just illustrated that it's a complex process, and you need to have the right people on your team going through this. But what I really want to emphasize to people is that don't take the subject of power lightly, because if you overlook one critical component, either as a company occupying the space, you might have insufficient power for what you need in there. Or if you're a property owner who buys a property that has insufficient power, then as you could hear from Bryce, it's a lengthy process of going through the engineering to figure out what's even capable of upgrading it, dealing with the service provider, and then just the cost of it. I can't emphasize enough how important it is to do your due diligence on that, either as a company or a property owner, beforehand, to avoid running into a potentially unfixable mistake. So I'd really encourage people just to keep power top of mind, particularly as we're going into this environment where there's just going to be more power demand for everything. There's going to be more of that broadband connectivity, which is going to require power, more robotics, more things just connected to everything. So really keep power on the top of your mind. And I do want to get to some questions here, because I had one come in from Ron Rody on Twitter, and I don't know, this might be the same as you answered on another question, Bryce, but perhaps you can just take it in whatever direction you want. But he was asking about tracing wires for dead outlets or lights, and in the context of like a large industrial parcel of land. So maybe it's outdoor storage, maybe it's a laydown yard, whatever it is. If you have dead outlets or lights on the site, is it worth trying to trace where all those wires are going, or does it make sense to just trench a new line altogether?
Yeah, so if you can assume that the actual like receptacle and lighting is all still in good condition and can continue to be reused. So yeah, the fork in the road is, can you try and reuse the existing wiring and infrastructure, or do you just run a new one, and whether you abandon the other one in place or whether you try and rip it out after the fact. But a lot of it comes down to, in that case, first, we would probably recommend that if you're going to attempt to reuse the cable, you can do what's called a Megger test, which is where you can use different voltages and instruments to monitor how good the insulation still is in that cable. There's some minimum threshold requirements for what value would be a pass on that test and what would be a fail. If it fails, we would just say, okay, well, end of story, don't use that cable. You're going to need new cable anyways. And if it passes, you can still look into it. But if you're trying to rewire using existing wire, that's where it's like, well, you still need to kind of know where that wire is going. If you're going to repurpose the cable, you still need to have an idea where it is. And so that's where you might have to perform some sort of excavation, and there's different ways to do that. There's like you can manually check it out. You can hydrovac and actually expose underneath. What you don't want to do is just kind of like dig with like a backhoe and just, you end up hitting the cable or the conduit and you break it. Well, now it's kind of a different beast. But if you are going to be attempting to reuse existing external infrastructure, at a minimum, I would say you'd want to first even see if you can use the cable, and if you can, then usually you're trying to physically locate it. If you don't have any sort of as-built information that actually verifies where that is, then typically you still want to try and expose it to confirm if you need to see where it's going. If it's simply the receptacle is there and all it is in the building, there's just this wiring that has yet to be connected, then in theory you can still use that and extend it out to a new panel, a new power source, and re-energize that equipment. But at a minimum, you'd want to do those field checks to confirm that the equipment is still reliable, functional, that the cable going to it is still functional and sized appropriately, and then kind of go from there.
Yeah, good answer. Just to backtrack one more time, because I did have another question about a building. So if a property has, and we'll just use arbitrary numbers again. Let's say it has 400 amp power, it's three-phase, it's advertised as 208 volt. And assuming that there's a transformer on there, either a pole mount or a pad, for a company that perhaps needs 600 volt, is it right to assume that that 600 volt can be there by changing the transformer, or does that require something more robust?
Typically, if you already have 208 volt three-phase for a transformer, I would be very surprised if utility can't just swap out that transformer for something that has a 600 volt secondary, because the voltage on the line should be one typical for my geographical area is like 15.6 kilovolt is what that line is. So as long as it's like less than that, then you should be good to go. So if we had to upgrade from a 208 volt three-phase service to a 600 volt, on our side, normally it's just, you just have to kind of switch out that transformer. The cable will be oversized at that point, but oversized cable is fine, unless the cable is no good, in which case we'd also just replace the cable and get it all new. So that, because that's another thing too, you want to be careful of reusing too much existing stuff, is everything has a life cycle to it. And so if you're going to put in all new shiny equipment that's all brand new, sometimes it's like, well, if we just do all the install is new, you don't have to worry about checking out that existing cable every few years to see if now it's finally at the end of its life. Now, like this whole system was replaced in 2022. Therefore, we should be good for like 25 years, subject to operation and maintenance, checking things out as required to confirm.
So you conceivably it should be easy enough to increase the voltage if necessary, but if it's single phase, going to three phase is a lot more onerous, as well as going from 200 amp to 400 amp. That requires a lot more due diligence and identification to see if it's even possible, and then there's typically going to be a larger cost and time involved in that.
Yeah. Current upsize involves some additional utility infrastructure, and it also affects like cable sizing, as well as you have to check out the equipment inside your facility to see if you can handle that. The biggest bane would be, if you were trying to upgrade from single phase to three phase, that can be a potentially costly thing, and that really depends on if utility has the physical infrastructure developed in the area to accommodate three phase. I am actively working on a project where this came into play, and we're like, well, you can upgrade to three-phase service, but just as an FYI, like it'll be like $100,000 per kilometer if we're going to now start pulling in. So it's like, oh, well, that puts things into perspective that like maybe the better option is so that's the example where we used variable frequency drives to convert single phase to three-phase power for the one piece of equipment that actually needs three-phase power. Everything else can be provided in single phase. So we still get a 120 240 volt single phase service, and then use those variable frequency drives to convert to three-phase power for the dedicated equipment that needs it. Everything else is all single phase. So now we don't have to spend $100,000 to upgrade our service from
Hmm.
single phase to three phase.
And then notwithstanding even the cost of doing that, what's the time? What's the time involved if you're trying to increase the current or you're trying to increase from single phase to three phase?
Yeah, that's a great question because utility would have to say, well, based on our current workloads and all of the people that have submitted applications, we can slot you in for this fall. So it depends on the reality of like how booked they are and where that fits into their timeline. So unfortunately, like as a tenant, you don't really get too much of a say in the matter. It ends up coming into like what utility can accommodate.
And so again, not to beat a dead horse here, but if you're a tenant or a property owner, not knowing this in advance can kill a deal. I mean, we all know time kills deals, and if you have a property and you can't even bring in the service for 6 months, call it, because you're at the mercy of the utility company, that could easily kill a deal. So it's incumbent on tenants and landlords to be getting ahead of this as quickly as possible. So thanks for clearing that up too, Bryce. I think we had a couple questions come in here, Wyatt, if you don't mind pulling them up. Is it possible to upgrade from single to three phase? Warehouse investor, thanks for the question. I think we've cleared that up, Bryce. It's possible, but there's cost and time involved in it. Anything else you'd add to? Because I guess there's uncertainty too, so it might not be possible.
Yeah, like for example, there's one project that was like up in the mountains, so it's just like you really have some special case scenarios at play about what you can like even do in those areas. So it's usually kind of rule of thumb is it can be done. It's just how much is it going to cost? And utility companies will sometimes consider your facility an investment. If your facility is going to use a lot of power, then they typically will give you a discount on the capital cost of the infrastructure depending on how much power you're going to use because they know that you're going to be paying them monthly long term for utility usage. So it might not cost you exactly $100,000 if they say, well, first of all, our baseline is we'll charge you $100,000 per kilometer. But because you're going to be using this much power per year, you actually only have to pay $60,000 per kilometer. So there are ways that you can still get discounts typically because utility companies often will consider like an investment. So then, but it's just be prepared that there will probably be a capital cost investment to upgrade if there is nothing immediately in the area to determine if there is no infrastructure in place for a three phase already.
Yep. And just from my own experience, most industrial buildings in major markets have three-phase power. Most of them do. I don't want to make a blanket statement there because the first investment property that I ever bought with my partner Ryan, we it had single-phase power. It was an industrial condo in an industrial park, but they only had a single phase to it. So we had to bring in a three-phase. It wasn't crazy expensive. That was back in 2014 or so. But I think by the time we brought everything up to standard and did everything, I'm pretty sure we spent about 20 grand on it. So it wasn't cheap, but it was possible. And I mean, 20 grand is definitely a big number, but it didn't kill the deal for us at least. Michael, thanks for the question. How does one know what voltage value a facility would use?
Yeah, that's a good question. And typically that is at the mercy of what the tenant's needs is. So for the process they want to accomplish, if they want to do a water treatment plant that's going to treat water, then you got to figure out all the equipment that needs to go in to accomplish that goal. Once you know that what that equipment baseline is that you're going to use, you start looking, hey, let's see what voltages these products are even available in. So once you figure all that out, then you can start figuring out, well, there's a common factor. A lot of this equipment is all 600 volt three phase. So maybe we should push for normalizing the facility to 600 volt. So part of the engineering of the design is to determine what that voltage should be. And often that is directly linked to what voltage can all these different pieces of equipment be provided at. Because from there, we can start honing in what voltage we should use for this facility.
A closely related question to that. If for a multi-tenant building where perhaps you'd just be consulting for one company in a very simple scenario, let's say it's a two-tenant building and you're consulting for one of the tenants, does that process also involve identifying what power will be remaining for the other tenant, or is that more just the responsibility of the property owner to be determining?
It depends on if each of those tenants has their own dedicated utility service or if they're sharing a utility service. Because if they're sharing a utility service, then everything has to be considered together to make sure that collectively the single. So what I mean by, I guess, by dedicated service versus individualized or shared would be if you have one utility meter that is for the whole building that happens to be two different occupants with two different processes, or do they each have their own dedicated transformer with meter going to it? Because if they each have their own dedicated meter and their own routing, they can individually do their own things. But if it's all funneled through a single utility meter, then the utility meter still has to provide power through that single meter to both occupants. So then at that point, you do have to consider all the existing loads as
Mhm.
well as the new or the upgraded loads. And
Would that
for each.
would that also include like future loads? So like as an engineer, I'm assuming in this two tenant building scenario that you would go in and say, okay, the new tenant needs X and the existing tenant that's already there has Y, so the building needs X plus Y. Or is there any consideration given to the fact that tenant Y might become a different tenant altogether in a few years and they might have a different power requirement? Or like, I don't want to imply that that problem just gets kicked down the road, but I guess what I'd really want to know is from the property owner standpoint, how do you future proof the building from potentially becoming a problem if there isn't enough power for tenant YA 3 years down the road?
Yeah, no, that's an excellent question. We've had to figure that out on several projects, and by default, utility, I'm not going to say they don't care about the future loads, but when it comes to sizing their utility transformer, if you know you're going to put in future loads, by default they'll say cool, but for your immediate needs, this is the transformer size that we would put in to accommodate. So often, like on the engineering side, we'll still like provide the cable and everything size so that when that time comes, all you got to do is just switch out the transformer. There are some options where you can request an upsized transformer if you know that the existing one is just not going to cut it for when that future comes. And sometimes the utility will just charge you additional little capital cost for that upsized infrastructure that they're like, well, you don't need this upsized infrastructure. This is more money out of our pocket. So we would like to get reimbursed for that. So you can negotiate with the utility company, as far as I know from what I've done, I've been able to negotiate with the utility company to get an upsized transformer to accommodate for that future. Sometimes utility companies will even ask you, like, what's your future loads? And they may consider that in their transformer sizing as well. But more often than not, be prepared that if it's going to be a significant increase in size, that at the time of that, when that future comes, you might have to swap out your transformer.
Hmm, interesting. Oh, a comment from JD. Thanks for joining in, JD. He's a industrial professional in Calgary. So you're right in the middle of us, Bryce, between me and JD. Hi, Chad and Bryce. I tell my clients I specialize in short circuits. So contact your electrician to verify what you need here first. Yeah, that's a great point. Is that the last thing someone wants to do is make a disclosure about something and then have that liability on their hands. So I'm the exact same way. I never want to claim that I know what power is in there unless it's verified by an independent source. And like you said, Bryce, ideally right through the utility company, because they're the ones that have it on file and what they're actually feeding to the building versus potentially a panel. And you said that very well. It could be a panel that could handle 200 amps, but it might only have 100 amp feed in there at the moment. Is that correct? Did I paraphrase that?
Yep.
Okay. So I guess just to summarize, and we can still take another question or two if anyone has something to ask Bryce. But just to summarize, if you're a tenant, best thing you can do is hire an engineer to determine your load, whether it's an operating load or your peak load, or both ideally, and find a building that's compatible with that requirement. So I think that's pretty straightforward and sound advice for a tenant. On the property owner side, it's still incumbent on the property owner to determine how much power is coming into the building and also be careful on how that power is allocated, because if you give too much power to one tenant and you don't leave enough for future tenants, then you could be in a position where you've either got to upgrade the amperage, like we've talked about, or add a new transformer to increase the voltage. And that can just come with problems on whether the building is even capable of handling it with the conduit and the wiring that's there, as well as the service provider being able to accommodate it. So there's more risk, I think, on the property owner's side if they're not staying on top of it. But there's also risk for the tenant, because if they find a building that they thought was compatible, or they didn't build in any future requirements for their power, they could also be stuck in a position where they have an inadequate power. Is that fair to say on how I tried to summarize our hour talk in a minute there?
Yeah, for sure. And also just a reminder, this is like dealing with industrial applications, which is something different than like residential or what, like condos and stuff like that. Like my answers are tailored more for like industrial facilities. So
Yeah, thanks for clarifying that too. And that is a good point on that. Well, Bryce, you're a fountain of knowledge. You're very well spoken on this. I'd encourage you to do more podcasts too. You're a natural at this, and you obviously bring a lot of value. So I'd encourage you to consider doing more podcasts. And I really do appreciate you taking the time to be on here. Beverly has put a few links on how to connect with you on LinkedIn. And Bryce, I just really wanted to say thank you again for taking the time to join me on this call.
no, thank you very much for having me. I appreciate it.
Okay, well, let's keep in touch as well.
All right, thanks.
Okay, see you, Bryce.
Yeah.